All right, so this video is on similar figures. You should see that it's 2.5b, so the video is 2.5b for Math 8, and the video is similar figures. So a couple of ideas here about similar figures. Like similar figures, we have to realize are the same shape in a lot of ways. Like they're not just the same shape like two rectangles, right? These two rectangles would not be similar. This rectangle and this rectangle. These aren't similar, even though they have all 90 degrees. Similar figures have to be very much the same figure, but then taken, right, and then made to a different size. So the same exact shape, the same exact ratios, right? Oops, that's not right. But really, that's what makes it a similar figure. So similar figures have something really in common. They're a little more specific. So the big idea is that these are similar figures here, these two triangles. They're not necessarily the same size, but they do have angles that match up. So the corresponding angles are congruent. So what I'm saying is that there's a set of angles that are congruent. So let me show you what I mean by that. I mean that A corresponds to D, so these angles are both congruent. And that's a pair of congruent angles. Okay, so just like you're pairing like socks or something, you know what I mean? This is also a pair of congruent angles. We would call these corresponding angles. These two guys here are corresponding angles. And you can also look at, let's say, the last two corresponding angles. Think about what those might be, the last two that I haven't highlighted. And that would be angle F and angle C. Those are corresponding angles. You'll notice that these arcs here show that those angles are corresponding and congruent as well. This means congruent to this. So those are congruent to each other because they both have one arc. So let's say angle B is 70 degrees, then angle E is also 70 degrees. So that's one part of making two figures similar. But the other thing is that you also have to have corresponding side lengths that are proportional. So what does that mean? Let me highlight that for a second. Corresponding side lengths that are proportional. Well, what that means is all of this stuff below here, this thing. It means that the side lengths that are in between. So if you look at, like, let's say we look at the arcs, right? And we say this guy has one arc, right? And this guy has three. You see? 3 arcs in between it. Well, that side that corresponds, that's in between those, that's sandwiched in between them, is red. It's this right here. It's side DE, right? And we want to do the same thing over here, and we want to say, well, this is in between the 1, right? This is 1, and this has 3 arcs. So these are corresponding angles as well. And we'll notice that this side. Now, AB has to be proportional to DE. That's kind of the idea here, or similar to, or something like that. This is basically just saying proportional to. And the way you'll do that, and that's not great notation, but the way you'll do that is by looking down below, and you'll be setting up a proportion. So if you take those two guys, A, B, and DE, and put them into a proportion, they will match really well with the blue side. So pay attention to the colors here, and hopefully all of this is making sense. So the blue side over the blue side. Now you'll notice also that sometimes we set up this like square thing, right? Looks kind of like this. And it shows that anything in this row or column, they have something in common. There's something special about them together. So if you look at this row here, right? If you look at this row, let's say, for example, the top one, you'll notice that these guys, both here, A, B, and BC, are both from this triangle, right? And if you look at the bottom row, right, we look at this row right here, you'll notice that both DE and EF are both from this triangle. So there's a lot going on here, and I think this will be more concrete with some examples. So I don't want to spend too much more time here. I want to get to some examples. So let me show you the first thing that I would like to talk about. Are these figures similar? And give me your reasoning. So let's just talk about maybe a little bit of this. I don't think you have this in front of you, but let's talk about, there's two things we need. We need the angles, right? We need the angles to be congruent. That's number 1. So that's a question. And that we'll make a checklist here. We need that, and we need them both to be checked off. And then we need to have the corresponding sides to be proportional. So those are the two questions we got to answer. Well, when I look at this one and I look at this as 90 degrees, right? This is 90 degrees, right? This is 90 degrees, this is 90 degrees. They're all 90, this is 90 degrees then, and this is 90 degrees, right? I mean, presumably, there's some things that are a little bit off about this diagram, but we're going to assume that these are both rectangles. They're the same shape in a lot of ways, but so are all the angles congruent? Yeah. But are these two things proportional? That's the next question we have to ask. So how do we do it? Well, what I would do is I would either take, and it's a lot of ways you can set this up, but why don't we take the short side over the long side and just write a fraction with that, short side over long side. Okay, and now over here, why don't we take the short side over the long side? So we'll do the same thing, short side over the long side. What we're looking to do is, if we multiply diagonally, cross products, if we multiply that and we multiply that, and they come out to be the same, then we'll be in good shape. So let's look at the two cross products separately, okay? So first we'll look at the green cross product. 5 times 15 is 75. Okay, and then we'll look at the yellow cross product, but for now I actually kind of want to change that from yellow so I can use that color again. So let's use, instead of yellow, let's use blue. So the blue cross product, we'll call it. So the blue cross product is 12 times 7, and that's 84. So if that was equal, then we'd say corresponding sides are proportional, but they are not. So I'm going to put an X there, and I'm going to say no. These are not similar figures. Okay? Let's keep on going and see if we can get anything else from this. So how about this guy right here, 3? There's other ways of doing this, but our favorite thing to do is find out if we have, let's see, corresponding angles congruent. So corresponding angles are congruent. Whoops, this is the symbol for congruent, by the way. That's the first question. And then are the corresponding sides, are they proportional? Are they proportional? That's what we want to ask ourselves. Now there's one thing that's always going to kind of overrule everything else. If the corresponding sides are proportional, this is the big question that we need to ask ourselves. Because if they are, if all of the corresponding sides are proportional, then the figures are going to be similar, as long as they're the same shape. So we have triangles here, right? And if we look at the corresponding sides, we could put 8 over 10, which is the short side over the long side, 8 over 10. And we could also take 12 over 15, and that's the short side over the long side again. And if we do the cross products out, we take 8 times 15, which is going to be 120. And then we could take 10 times 12, which is going to be 120. So that's showing that these sides are proportional. So I'm saying proportional, 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 proportional. Now, by Pythagorean theorem, we could figure out, and I'm not going to show this, I'm just trying to give you an idea. Well, actually, it doesn't come out very easily by Pythagorean theorem. Not as easily as I thought. So once the corresponding sides are proportional, this is kind of an automatic that the corresponding angles are going to be congruent. So the corresponding angles will be congruent in this case. Especially we have one angle here. This angle is going to be congruent to this angle, and this angle is going to be congruent to this angle. So we're in good shape. So that's kind of what we're trying to do here. So let's just go into some more examples here. Which rectangles are similar? So if you look at this right here, if you look at the 3 over 6, the ratio here, there's a lot of different ways of doing this. 3 over 6 is 1/2. This is 1/2. So the ratio of the short side to the long side is 1/2. If you look over here at the 2 over 4, right? Well, the ratio of 2 over 4, well, 2 divided by 4 is also 1/2. So that's a similar ratio, right? They're the same ratio. And then here, if you look at the 2 over 6, right? You got 2 over 6. Well, that's going to come out to 1/3. Okay? So you can say which rectangle is similar to rectangle A. Well, it's not rectangle B. It's the ones that have the exact ratio of the shorter side to the longer side. So C is similar. So when you have two figures that are similar, you need to set up a proportion and then cross multiply to find x. So they're telling you they're similar. They are similar. They've already told you that. So now we can set up a proportion to find x. So I want to make two different things here with an in between. Okay, and I want to look at two things. Let's see. Let's start with the short side, which visually is here, over the long side. Short side over the long side. And then in this triangle, let's do the same thing, short side over the long side. So this has to be true. It has to be true that x over 6 equals 6 over 9. So I'm going to cross multiply. I'll show you what I'm doing. I'm taking this and I'm multiplying like that. So that's 9x. And then I'm going to take 6 times 6 and multiply that, which is right here, 6 times 6. And that's going to come out to, let's see, 36. So 36. So this has to equal. And we're going to then realize that when we divide by 9 on both sides, we'll have our x value. Our x is equal to 4 in this case. So that's the missing side, okay? I want you to pause the video and try this problem right here. Try this problem right here, set up a proportion, and find the missing side. I'm just going to reveal the answer to this problem, so hopefully you've paused the video and you've tried to figure out what it is. I want you to know that x is equal to 24 centimeters. That was the answer. So hopefully you got that. If you didn't, make sure you're reaching out or rewinding to figure out what's going on, okay? Lastly, or maybe one of the last things I want you to do is I want you to take a second to sketch below this, right on your paper, sketch two figures that look similar, right? And tell me how you determine if they actually are. Maybe they look similar but they aren't. Maybe they look similar and they are. I want you to sketch two figures that to you look similar, okay? And then maybe write a little bit about how you'd figure out if they are similar. So one more problem and then we will call it. An artist draws a replica of a painting that's on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica, so we notice that they're similar trapezoid automatically, is 3.75 inches. What's the height of the trapezoid in the replica? So what I would do is I would look at a couple of things here. I would say, well, it looks like they're in the same exact orientation. There hasn't been a rotation or anything like that. So I'm going to take the shorter side and put it over the longer side of what I was given, which is 12 over 15. And then I'm going to take the shorter side of the replica and put it over the longer side, and I'm going to set these equal to each other. The shorter side is h, the longer side is 3.75. So really, all I need to do now is cross multiply and get an answer. Now I'm going to cheat and use a calculator here to get the answer to 12 times 3.75. So 12 times 3.75 is going to be 45. So when I multiply this diagonal, I get 45. So these set equal to each other. And if I divide both sides by 15, the height of this replica is 3. The height is 3 inches. Okay? So that's what we're looking to do. I apologize if that was fast. I'm trying to wrap the video up real soon. Wrap the video up. So if you had some trouble, you can rewind it. You could even slow the video down. Good luck with that problem. The last thing I want you to do before you are done is to just finish up with, I think this should be on your handout. The last thing I want you to do is just finish up with this problem, and I want you to think about this and try to answer this. So this is a now you try. So you try this problem, and then you are done. So come in with that done and come in with all the other notes. The very bottom problem I haven't covered, so we'll have to deal with that later. So good luck. And I will see you soon. Just give this one your best example. You could draw them both out and do it straight up, or you can just try to figure it out logically. I will see you soon. Peace.